everyone, my name is Vidit and I'm from Dr. A.P.J. Abdul Kalam Technical University. So the topic of today's presentation is intelligent skin cancer detection using convolutional neural network. So, wait just a minute. Yeah. So today's topic was that using CNN we are going to detect cancer at an early stage. First, the question comes, why to use CNN when we have many advanced technologies to detect cancer, like dermatological one, and there are many others of them. So first of all, the reason is supply of doctors, especially in developing countries like India, is limited. And especially in smaller towns and villages, it's making difficult to take
Sorry to
the
interrupt, but did you start showing your presentation? Because we don't see anything right now.
um, is it visible now?
Let's wait.
Okay.
Yeah, we can see right now.
Okay, so I will start now. First of all, the question is how to use CNN when we have many other technologies there to detect the cancer. First of all, the supply of doctors is limited in developing countries like India, especially in smaller towns and villages. That is making provision of healthcare difficult to a larger group of people. Secondly, it comes the cost factor. The cost of a cancer test in India is 4,000 Indian rupees. If we talk about Turkey, it's about 400 Turkish lira, and if we talk about United States, it's about 55 USD. And the third point everybody knows is if it is not detected at an early stage, it cannot be cured. Now, in age of digital assistants like Google and Alexa, can we create cancer detection tools using CNN that can diagnose diseases like cancer at an early stage? So let's see. So, research indicates that most experienced physicians can diagnose cancer with accuracy ranging from 79 to 91%, but the machine learning techniques can detect this same task at the accuracy of more than 90%. In this case, our task is to detect three most dangerous types of cancer at an early stage using convolutional neural network. So there are only main three types of cancer that I'm classifying in this task. First is basal skin cell cancer, second is squamous cell cancer, and third is melanoma cancer. So what is CNN? In deep learning, a CNN is inspired by biological processes. You can see it is similar to the neurons that are present in the brain. So it resembles the organization of the animal visual cortex. Um, It is an AI function that mimics the working of human brain in processing data and for tasks like detecting objects and recognizing speech. It is able to learn without human supervision. So as you can see, in brain, the dendrites are receiving information from previous cells. Its nucleus is deciding whether to transmit the information to the next or not. Similarly, our neuron works like this. It takes information from previous neurons, decides whether to pass it to other neuron or not, and these are the passing out to other neurons. So first of all, I would like to know, does any all of you knows what is CNN, or should I tell? Okay, full screen. Wait. Is it fine now? So first of all, we are going to talk how human brain recognizes the patterns in an image. Uh, just take example of this 9 digits. We are piecing together this information part by part, like this upper loop and this stick upwards. Similarly, if we are recognizing it, it is going to be recognized by an upper loop and it's the lower loop, so that our brain recognizes like this. Similarly, if we want to recognize 4, we are keeping these many pieces together so that it can recognize whether what digit it is. So let's take this image 9. It is written on that, and suppose this represents 28 pixel by 28 pixels image. So this multiplies takes to 784 neurons. So just take his neuron as anything that represents a number between them. So for every pixel, we are needing a neuron. So for 28 by 28 pixels, we are needing 784 neurons. Okay, so every that neurons hold a number ranging from 0 to 1. So when it's 0, it means it's not activated. 1 means it's highly activated. So this is called the activation number of the neuron. This ranging from 0 to 1. Similarly, let's look how our neural network works. It works just as our brain works by passing information from one layer of neurons to other layer. So in the previous, we saw that it's a 28 by 28 pixel images. So this 28 by 28 forms the first layer of our neural network. See how it's processing images. It's detecting correctly as 7. Right now, I'm just telling you how a neural network works because it's a very similar, simple examples to tell whether how to explain a neural network in this. So you can see some of them are lighted and some of them are not lighted. So the lighted neurons means that the neuron is lighted and it will pass the information to all other neurons. If the neuron is not lighted, then it will. If it's not lighted, it's not passing the information to others. So the last layer depends how what is our example. In this task, our motto was to know which number is this from 0 to 9. So here are 0 to 9 neurons in the last layer. In my task, I want to just calculate. We have to classify the 3 types of network cancer. So in the last layer, we have just only 3 neurons, like 1, 2, and 3. First is for one type of cancer, second is for one type of cancer, and third is for other type of cancer. So you might be wondering, what is this hidden layer between the neurons? So these are the hidden layers that are doing all the complex computational work inside a neural network. I will come to later how this is working in a practical demonstration. Let me see if I have some questions. Okay. So everything clear till now? So I told you above how our brain works. So similarly, if we take about neural network, CNN, it's pretty works in the same way. Every neuron in a hidden layer can recognize the hidden patterns in an image by subcomponents inside neuron. We saw here, just a minute. Yes. In the previous example, we saw that these things human brain recognizes by matching these little edges, by piecing them together to information with what number it is. So yes, that's a representation of a neural network. See, 9 is drawn by pieces, and it matches this loop. So this neuron is getting activated, and at the end, it's showing that it's 9. Similarly, it will work for 8. All the loops that have that circle inside them, they will be getting activated, and at the end, that number will be lighted up. See, that's another representation how it works. All this forms the first layer of the neural network. All the edges are associated with this are lightened up, and these edges are forming the complex pattern, this hole and the stick. So as last, the 9 is being lighted up. So each hidden layer, this is hidden layer I told you before. And this is also called the convolution layer, which works by using filters that can detect the patterns in image. So these small things, this are all filters that are recognizing which type of pattern is hidden in the image. So it also pretty similar works in the same way. Like this is the photo of lion. It's working complex on complex edges by detecting the edges and like matching the filters that are trained in the neural network. Now you will ask that how does this activation work? How does this neural network know which layer to activate, which neuron to activate? So the answer to that is activation function. So it is added into neural network in order to help them learn complex patterns in the data. So the activation function decide whether to activate the neuron or whether to not activate it. So if our activation is coming more than this, I mean in this part, it is activated and the data is transmitted to the next layer. If the activation is less than this, I mean in this part, it's not going to be activated. You might have studied these sigmoid 10H functions in your previous classes, ReLU or maybe LiQReLU too, but these are specially used for neural network tasks. Yeah. Okay, so this is the perfect representation of a neural network. Here we are recognizing just faces of the people. So the first layer, take it as a first block. So this block is representing smaller edges like, or smaller features you can say, like lips, eyebrows, eyes, hair. Next it feeds the data to the more complex features like eyes and complete part of a face and half part of a face, like that. Next hidden layer is recognizing more complex features such as the whole face of the person, and in the output layers it is classifying whose face it is. Okay, so here's the representation of an image, and this is also example of filter. I will tell you in a minute. Wait. So just think this 1 1 1 1 1 1. So this is a filter of 3 by 3 matrix. So this filter is made to extract any patterns that are similar to X in the image, and that it will make a future matrix from that. Okay. So next we are coming to concept of it was just 28 by 28 pixels images before. What happens because in the digital age our images are of 4K, and this is the resolution these days, like 180p is 1080 into 1080 pixels. So this is going to be a big number for the first layer and it will be computationally expensive. So what we are doing is we are transferring the 4 by 4 matrix into a 2 by 2 matrix so that our computation is becoming easy. So we will be taking maximum of these 4 and we will be storing it here. Similarly, the maximum of these, we will be storing this here. Similarly, in average pooling, we are taking average of these layers. So what's the average of this one? 3200, it will gonna be 8. So this is gonna be reducing the complexity of our network. This can also represent it in a block diagram. As you can see, it's a convolutional and the activation is ReLU. I showed you this ReLU. So if it's gonna be more than 0, it's gonna be activated. Here we have applied this pooling as I showed you before, this pooling. So the pooling has reduced the size of the net block to just half. Similarly, again, we have used convolution. Again, we have used pooling that has reduced the size of the matrix to half. So again, at the last, we are seeing this softmax layer that is going to be tell us it's car, truck, van, or bicycle. Okay, so let's come to the background study of the cancer detection that I've studied. So I read few papers. So in that first paper, it was mentioned that 2-layer convolutional network is used for melanoma classification. So it used mask generation, Gaussian filter applied to you remove noise issues. But the main problem with that was 80% accuracy. It's not something we can say it's highly accurate in the task of cancer detection. So he should have been used more training data, more deep network that I have used in my project. Similarly, in the second example, the neural network used UNet-based algorithm that was proposed for medical image segmentation at expert level. The accuracy was not defined, but we cannot use it in real time. So what's the use of something if we are not able to use in real time? Next, if we see this one, classification of benign and malignant skin lesions was used, and this used hybrid deep learning model named the MobileNet. Again, we can see the accuracy is so less. So the main problem was because he was using Raspberry Pi, and the computational power, it's so less in Raspberry Pi. At last, if we come, his main aim was to identify the apps available to detect melanoma. So again, we can see so less accuracy was there, 80% for all two applications. So it has used ABCD algorithm, so this can be problematic later. So here starts the main principle of my project. So we took the images of the early level of the cancer, that is HAM 10,000 data set that is available as the multi-source dermatoscopic images of common pigmented skin lesions. So here starts the deep learning task. So the data set I got is split into 70% for the training. Like suppose I have 10,000 images. I have kept 7,000 for training purposes, and I have used 3,000 for the testing purposes. I will tell you later about this. So the training, we are feeding the images to the neural network, and it's going to be trained again for classifying the cancer. And this testing data set is used for testing how accurate our model is. So testing, we can also say it as a validation set. I have used that name. So transfer learning I have applied onto my models. I will tell you what is transfer learning later. For image-based classification of any other application for bioinformatics data set. So right now I've used for classification of diseases only, but it can be used for like signal processing and voice processing and many other tasks. Yeah. So this was my approach. First of all, we will be scanning the skin of the infected person, or it's infected or non-infected, with the application which has been trained using CNN. So this CNN has been trained using the deep learning convolutional neural network. So after the scanning, it will tell whether the cancer is identified or not. Then it's gonna be tell which type of cancer it is. So this is transfer learning that I have used in my project. So actually, Stanford University has trained over 14 million images on its neural network. So we can say it's highly accurate and such a large database of images. So what I did was I just removed this last layer from the set, and I use it for classification of my project, that is 3 types of cancer. So my project has 3 layers at the end. You can say I removed this layer and I connected it with the layer I have to train in my project. Yes, for the new classes that have 3 types of cancers. So this is the complex network that has been used in the project. This is called the SSD MobileNet. I'm going to tell you how we can see the dimension of the neural network in the practical session. So the uniqueness was we are using CNN for early stage detection. So cloud computing, I will show you using this on Google Colab. So it's completely free. You can use it for all the deep learning tasks. Secondly, of course, it will reduce this human effort, and cost plus improved accuracy will be there. So this TensorFlow is the machine learning library or deep learning library. These both are, I have already explained you. I will be telling you how to use cloud in the further presentation. And Android for transferring the CNN model into the Android. So this was a working prototype, but this was on microscopic images. You can see it is classifying melanoma, dermatofibroma, and this other one with the high accuracy. So, okay, so I'm gonna tell you the basics. First, let me check for questions. Basically, we have to give number of output. try this like yes, the last layer of the neural network is going to be the number of neurons will be equal to how many cancer. Like I've classified 3 types of cancer, so last layer will have 3 neurons in that. If suppose I had to classify this, my task was to classify 0 to 9 digits, so it is from 0 to 9, so it has over 10 neurons in the last layer. This layer is also called the softmax layer. I'm going to tell you in the coming session. Okay, so let's start the let me authorize it. So this is Google Collaboratory that can be used for any Python task or any deep learning task. It's completely free. You can use GPUs, CPUs, TPUs, and you can run it for almost 9 to 10 hours without any costs. Just a minute, let me log in. So these are the libraries that are going to be used in my classification of cancer tasks. So this Matplotlib is a machine learning library. This TensorFlow is used for the same task like deep learning and machine learning tasks. So in TensorFlow and Keras is also this deep learning library. So I'm importing these layers and this model class from that. All these are the types of layers in the neural network. I told you this conv 2D layer is in the presentation. Max pooling, I told you this one. This one is a max pooling or average pooling. You can use any of them. Dropout layer, I will tell you. Flatten and dense are the last layer of the neural network, as I told you in this one. This is the last layer that is called softmax layer. So this is the base directory where I stored all my images for cancer. Wait just a minute. So yes, I came to ML and AI, and this is the cancer. So as I told you, I have reserved, where is that? So I have used 70% of data for the training task, and I've used 30% for the testing task. So this is the train directory, and this is the validation directory as it is mentioned. It's just appending the train to the last path, just like this. Similarly, this one is appending validation path for this. So under the inside the training and validation path, we have actually this one is different from my project. I have used other types of cancer in this. First of all, this is Benign Keratosis cancer, and second is melanoma, and third is the case if we have no cancer. So if we come to this train directory, we are going to see Benign Keratosis, second is melanoma, and third is no cancer if we don't have any cancer. So no cancer is like if we have pimples on our hand or some other task on our hand. Like this is not cancer, this is some other diseases. So if it's not cancer, it's in the category of no cancer. Similarly, this is the Benign Keratosis. See this? Now I am going to come to this validation task. Similarly, it has 5 images. So this is the train directory for the Benign Keratosis. This is the train directory for melanoma training. And this is the no cancer for the other one, like training path. So this is for the validation path in which we will be testing on our images whether it's cancer or not. It is the training directory for training our neural network on the images. I will tell you how many images I have used later. So it will tell you, wait, yeah, it's gonna tell you how many images I have used for benign keratosis, how many I have used for others. So see, training images for benign keratosis is 15. Similarly, it is 15 for melanoma. Similarly, it's 15 for no cancer. For validation, or you can say training one, as I told here, is for training one. I mean testing one. We can say it as a validation one also. For validation, we have used 5 images. So in total, training images are 45, and testing images are 15. Okay, so this train image generator class will, okay, we have just 45 images for training. So these are not enough for machine learning or deep learning tasks. At least that needs about 400 images to train on the neural network so that it can get a high accuracy of more than 90%. So here we have wrote C like this. This whole function works in the similar way. This rotation angle rotates the image on various 45 degree, like rotating 45 degree like this, rotating on some other angle like this. This one width shift range is gonna shift the image to right or left in the width, and this height shift is gonna be shift the image horizontally in upper or lower direction. Zoom range means it will gonna be zoom the image for more than 50%. And horizontal flip is just like we are flipping the image horizontally. It is true. And I have avoided the vertical flip just randomly. Let me see for questions. Yes, I will tell you what's the math behind that. It's very complex integration, differentiation, linear algebra, matrices. I will tell you just after that. So this was for training, and similarly, this is for validation. Now the training process is going to start in some time. Yeah, wait. Okay, so there are 45 images that are belonging to 3 classes. So we are going to train in a batch size of 3. I will tell you how this batch size works. The directory from which it will pick the images are this training directory. Mm, this train directory. So the target size is gonna be 150 by 150 for these images. Actually, the size of these images is different because some of them it is 150 by 150 pixels. Some of them they are 200 by 200 pixels. So that's why we have fixed the size in the first layer for our neural network. For this layer, we have fixed the size for this input layer. Yes, so the color mode is RGB, red, green, blue. That is for usual these images. So in validation for testing purpose also, I have sorted the images as 150 by 150. So leave this one. Okay, so this code is gonna show you our sample training images. So these are the images after we have applied some rotation or some other principle to them. See, this one, this one, this one. So I have resized them to this 150 pixel by 150 pixel. You can see every image is that size. Now comes the main part of our neural network training. So this is the keyword that we are going to write in every of them. Okay, so first layer, the first layer of our neural network. I am writing down this in the first line. So yeah, this is a convolution layer. I will tell you what's the convolution layer after some time. So this has 16 filters. 16 filters. I told you what are filters in this presentation. These are filters. These 1, 2, 3, 4, like this. So they are going to identify the cancer image in this. And the size of that filter is 3 by 3. Just like this. This matrices is like this, 3 by 3. This is the size of our filter. Mm, the activation is ReLU that I told before, and the input shape is 150 by 150. As I told you, this 150 by 153. And this three parameter means we have three colors. This image is made of RGB, red, green, blue color. Okay. So as I told you, I have made the max pooling. After that, I have reduced the size of the layer to half like this. I've used max pooling in this layer. So the size of the block is going to be reduced to just half. Yeah. So you can see it was the dimension of that. And secondly, you can see this was the dimension. It has been reduced to just half layer because we have used max pooling. Now it comes dropout. What we have did here in dropout is, imagine this layer is transferring all to all the image neurons. I mean in the next layer. 0.4 dropout means the 40% of these layers will be off. Like I have purposefully did that so there is no overfitting in the neural network. See, like 40%, like these 40% of this layer will be activated as zero, and they will not activate it, and they will not pass to the other layers. Similarly, I have repeated the process. This time I have used 32 filters. They have still the same size. Ignore the padding for now. And activation is again ReLU. So this one is this. After dropout is the size is this. So again, I have used max pooling. Again, I am reducing the size of the network to half. See, half of 75 by 75 is 37. So it has been reduced to half again. Again, I have used this convolution layer. Again, I have used this max pooling. Again, half of 37 is going to be reduced to 18. Now, again, I have used dropout. Again, the 40% of layer are not going to be activated. Now I've used the flatten layer. After that, I have used the dense layer. And at the last C, I had the task to classify as 2 cancer plus 1 is no cancer. So the last layer, as you asked me that how much layer to be in the last layer, how many neurons to be there in the last layer. So this is the answer. This 3 are to be in the last layer. See, 3. So these are the optimizers that are there in machine learning, deep learning. There's a loss function, there's an optimizer. So loss function means like how our model is doing as calculated to the real output, like how bad or how good our model is there. So this sparse categorical cross entropy is one of that. Yeah, it's gonna print model.summary. So now this is gonna learn from the data that I have fed it. See, I have used training data here. Validation steps are is equal to validation steps, that is I have declared in upper one. Steps per epoch is going to be 3. See, I am using 100 epoch for the training of the neural network. So per epoch, there will be 3 steps. Similarly, for validation, there will be 3 steps. So I'm starting the training now. See, yeah, the model has started training. It's going to take just a minute or two. Yeah. See, at last it's starting. You can see the loss function. The loss is like this, and accuracy is like this. Validation loss and validation accuracy. So here we can see our accuracy in the 6th epoch was so less, so it's gradually increasing as our neural network is learning. Like there's a thing called backpropagation. The output from the last layer is going to be feed it again to the first layer. That's called backpropagation. Again, you can see the loss is reducing by each and every step, and accuracy is increased by each and every step. Similarly, you can see validation accuracy. It's going to be like, I'm not saying increasing each by step. It will be like this, going up, going down, going up, going down. But at the end, it's going to be maximum. Yeah. Okay. For now, I had so less images for now. So let's see what's the accuracy for that. See, you can see it started from this gradient descent and it went to this much, this much, this much, this much, and at last it's gonna be to nine. It's about 98% accuracy that we are seeing here. So you can see that according to 45 images, we had this much accuracy. So if we had more larger data set, it's gonna be more accurate in that classification task of the cancer or even any other diseases, we can say. Yeah. Okay, so someone asked me that what is the mathematics behind that. So this is the mathematics behind that. First of all, we are using matrices in this. This differentiation is used in that this is the what we said as activation function used here, that we told you that sigmoid and ReLU for that. See, everywhere here we are using matrices for that. Here in backpropagation, we are using differentiation. You might have studied Jacobian differentiation, linear algebra matrices in your first year or second year of college. So this is going to be used in this neural network. So the task of this backpropagation is increase the accuracy of the classification task by slowly it will be increasing the accuracy of the network. See, you might have again studied the chain rule in differentiation. So this chain rule is also used in for improving accuracy, or slowly it will be like improving the accuracy of our network. See, this chain rule and all, they are all used in this neural network. So one neuron is gonna be taking yeah, this is the structure of our first and second layer, and this is the multiplication of these weights and the activation functions and bias. I have not told yet, it's a little complex thing. So yes, this is a complex mathematics. It's more than complex, but I will share this notebook so that you can see what is going on in this mathematics. I think it's just related to all first year college mathematics, and maybe you can understand it's better what's going on in this after looking the notebook. So yes, the conclusion was I have used transfer learning and it has used me save so much training time, and it has made a better accuracy. And instead of the old technologies to classify the cancer, and even that in early stage, we are using just a mobile camera to see whether we have cancer or not, and that too having a high accuracy for that. Plus, we will be reducing system overload, so that's another achievement for that. So, any questions?
Okay, thank you very much, Mr. Vidit, for this beautiful presentation. Dear listeners, thanks for your attention on behalf of RSG-Türkiye. Dear listening, uh, see you at another event. Good evening. Thank you very much again, Mr. Vidit.
So you can ask me if you have any questions now.